This lesson is on the beautiful math that everyone loves to see for figures and equations covering electricity for your general section of your airframe in Powerplant or in tests. Here we're going to be talking about capacitance today. If you haven't seen the lesson prior to this, check it out on our channel or just click the link in the description where you can view the entire subject. You get access to all of the videos, all the test questions where you can practice. So it's the way to go. Just click the link in the description. Watch it on our actual website or aviation.com. But here today, talking about capacitors, we have parallel and series circuits. We haven't talked about that yet. Lessons 14 and 15 are going to cover that. So we're going to try to keep it as super simple for now. And then we'll talk about it more later on in more lessons. The big thing that you need to know, so that when capacitors are connected in series, the components are connected in a row. So there's only one path for current to flow. And then in a parallel circuit, the components are connected alongside each other. So there's multiple paths for the current to flow. So let's first start with the capacitors that are connected in parallel with each other. So when they're connected this way, the total capacitance of the circuit, so the amount of electricity that can be stored up here, that goes up. So in this circuit, let's say there's 3 capacitors, and each one is rated to hold a certain amount of electricity. We'll say capacitor number 1 here can hold 0.02 microfarads. Capacitor number 2, we'll label that right there, can hold 0.05 microfarads. And then we'll say capacitor 3 right here can hold 0.1 microfarads. So the formula that we'll use on the test to find the total capacitance for this whole circuit when they're connected in parallel is the total capacitance equals capacitor 1 plus capacitors 2 plus capacitor 3. So in this situation, all we do is we're just adding up those 3 capacitors to get a grand total of 0.170 microfarads. That's for capacitors connected in parallel. So next, let's look what happens when we have them connected in series. So when they're connected this way, the total amount of electric charge the capacitors can store for this circuit, it goes down. This way it goes up when it's in parallel. It goes down when it's in series. So the amount that it can store is actually less than the capacity of the smallest capacitor. So I don't know about you, I'm a big visual learner, so we need to draw that out to figure out what that sentence is trying to say. So in this scenario, let's say we have capacitor 1 up here, and we're going to say that it can hold 0.04 microfarads. And then we'll say capacitor 2 can hold, say, 0.1 microfarads, and then capacitor 3 can hold 0.2 microfarads. So here, the total electrical charge they can all hold in the circuit will be an amount less than this 0.04, because this is the smallest capacitor here. It has the lowest capacity. So the formula that we're going to use for this is the total capacitance is 1 divided by, and then you have 1 divided by capacitor 1 plus 1 divided by capacitor 2 plus 1 divided by capacitor 3. So we're going to do the math on this one, because if you don't remember PEMDAS way back in middle school, you can get messed up on the test trying to put this into a calculator. So follow along with me. What we need to do first to find this, we know here's our capacitor values in microfarads. Let's find the bottom row first. Let's figure these numbers out first. So we're going to hold that 1 over, and then we're going to go 1 over C1, so 1 over 0.04. So that's going to be 25. And then we're going to have 1 over C2, so 1 over 0.1, that'll be 10. And then we'd have 1 over, let's see, 0.2, so then that would come out to 5. So now we have 1 over these numbers, that's going to equal here 1 divided by 40. And then for our grand total here, we have 0.025. Hopefully that's still showing up. Just got cut off there by a little bit. So just know that we got 0.025. So that is how you would calculate this for parallel in series. And don't worry, there's hope. Yes, I know math is not everyone's favorite, but you don't have to memorize these 2 equations on the test. So once you do those practice test questions on the website, you'll notice that they actually kind of give you these formulas and they prompt you which way to use it. So you do those practice test questions, you'll get a feel for it. This is how they're done. Follow this video along to get those first ones in, and then you'll see that you don't have to have these memorized. So click that link in the description, go practice these, get some reps in them, and it'll make things just make so much more sense.